Good morning. It's May 4th, and this is your daily brief in science. Here's everything you need to know. A new study links hyperactivation of the cGAS-STING pathway to liver inflammation in Down syndrome, tied to oxidative stress and DNA damage. Down syndrome genetic factors may predispose individuals to autoimmune or inflammatory liver conditions, suggesting potential therapeutic targets. The work places cGAS-STING within the broader DNA damage response and senescence-associated inflammatory signaling seen in Down syndrome. DS-derived fibroblasts show sustained oxidative stress, persistent DNA damage signaling, and heightened interferon activity, supporting a self-perpetuating inflammatory loop. Elevated ALT levels in a Down syndrome model indicate hepatocellular injury alongside this inflammatory signaling. Mechanistically, increased reactive oxygen species cause DNA strand breaks and micronuclei formation, releasing DNA into the cytosol to activate cGAS-STING. The study uses DS fibroblast and mouse models with RNA-seq and enzymatic assays to connect molecular mechanisms to liver pathology. Therapeutic implications point to antioxidants to reduce oxidative stress and inhibitors targeting cGAS-STING or related pathways. Temporal dynamics suggest early oxidative DNA damage triggers immune activation that leads to chronic liver inflammation, signaling potential early intervention windows. Future directions call for preclinical and clinical validation of cGAS-STING inhibitors and antioxidant strategies, along with biomarker and personalized medicine exploration for DS-related liver disease. A new study on mouse hippocampus challenges the blank slate idea of memory development by showing that early brain networks are highly interconnected and then refined through pruning. Researchers tracked CA3 pyramidal neurons across development, using patch clamp recordings, advanced imaging, and laser-based techniques to map how memory circuits form and stabilize. The work indicates memory wiring starts densely connected and becomes more organized as pruning narrows unnecessary paths. Led by Peter Jonas with Magdalena Waltz, professor for life sciences at ISTE, and Victor Vargas Barroso directing, the findings appear in Nature Communications. The publication frames memory development as a process of selection and refinement, rather than simple expansion. The study specifically examines development from early postnatal days 7 to 8 through adolescence and into early adulthood to see how internal networks evolve. Limitations note that brain slice conditions may not fully capture live behavior or human memory. The broader takeaway is that brain development favors early extensive connectivity that is refined over time through pruning, challenging tabula rasa notions, and suggesting a predisposition toward structured network optimization. This pruning model replaces memory formation myths with tabula plana, where initial exuberant connectivity provides routes that experience later sculpts through selective pruning and strengthening. The findings advance understanding of how memory and spatial navigation networks mature and point to future work, identifying experiences that guide pruning and whether these rules apply to humans. A Warwick University team used an AI-driven pipeline called Raven to sift through NASA's test data and confirm more than 100 exoplanets, including 31 newly identified worlds, from observations of over 2.2 million stars in TESS's first 4 years. Raven's analysis validates 118 new planets and identifies over 2,000 high-quality planet candidates, with nearly 1,000 entirely new, creating a well-characterized sample of close-in planets for follow-up studies. The newly identified exoplanets include ultra-short-period planets, orbiting in under 24 hours, and planets in the Neptunian desert, along with tightly packed multi-planet systems around some stars. The study highlights diverse planet types, noting ultra-short-period planets, planets in the Neptunian desert, and tightly packed multi-planet systems around the same star. The Raven pipeline streamlines detection to statistical validation, enabling consistent, objective analysis of large datasets and robust sampling for studying planet populations around Sun-like stars. Beyond detections, Raven's broader impact includes enabling reliable, large-scale identification of planetary signals, reducing biases, and improving understanding of how common different planet types are across the galaxy. The study released interactive catalogs and tools so other scientists can explore results and identify targets for follow-up observations with ground-based telescopes in future missions like ESA's Plato. TESS is now rivaling or surpassing Kepler for studying planetary populations, especially close-in planets, aided by the interactive catalogs and follow-up planning tools. The findings, published in monthly notices of the Royal Astronomical Society, are based on data from more than 2.2 million stars over TESS's first 4 years, focusing on short-period planets with orbital periods under 16 days. Raven validated 118 new planets and identified over 2,000 high-quality planet candidates, nearly 1,000 of which are entirely new, enabling targeted follow-up studies. The results demonstrate that AI-driven astronomy can efficiently handle massive datasets, improve the reliability of planet catalogs, and refine population statistics for different planet types. Complementary analyses quantify that about 9 to 10% of Sun-like stars host close-in planets, with uncertainties greatly reduced, and Neptunian desert planets occur around roughly 0.08% of Sun-like stars, establishing precise occurrence rates. India has unveiled its first national guidelines to screen, diagnose, treat, and manage childhood diabetes within the public health system, offering a comprehensive, free-of-cost care package at public facilities. The framework aims to cut mortality and long-term costs by emphasizing early detection, prevention of complications, and a better quality of life for children, while building capacity to handle pediatric non-communicable diseases. It creates an integrated continuum of care that links community screening, district hospital management, and advanced care at medical colleges for seamless detection to long-term follow-up. Beyond protocols, the document lays out evidence-based treatment guidelines, regular monitoring schedules, and complication prevention measures to ensure accessible and equitable care. The package covers screening, diagnostic services, lifelong insulin therapy, monitoring devices, and regular follow-up, reducing the financial burden and ensuring uninterrupted treatment. The guidelines are part of Rashtriya Bal Swasthya Karyakram, targeting early detection and intervention for 32 common pediatric conditions, with care pathways extending to tertiary facilities. Public health benefits cited include reduced mortality through early detection, prevention of complications, improved quality of life, and long-term cost reductions alongside strengthened capacity to manage pediatric NCDs. Universal screening from birth to 18 years is mandated, with early identification via community and school platforms, mandatory blood glucose testing for suspected cases, and timely referrals to district facilities for confirmation and treatment. Family and caregiver empowerment is a focus, with training on insulin administration, glucose monitoring, emergency response, and daily disease management, aligned to standard guidelines. The initiative signals the government's commitment to accessible, affordable, equitable, and high-quality healthcare for all children, prioritizing early intervention and continuous care. The 4TS framework, toilet, thirst, tired, and thinner, helps parents and educators recognize early signs of type 1 diabetes in children. While type 1 remains more common in childhood, type 2 diabetes is rising among youths due to obesity and sedentary lifestyles, with risk factors including obesity, inactivity, unhealthy diets, family history, maternal gestational diabetes, and related conditions. A grounded ice body over a flat bed has set off buoyancy-driven calving, triggering a rapid retreat of a thick floating ice tongue and contributing to sea level rise. Scientists used remote sensing data to trace this sequence and its link to warming in the region. The Larsen B collapse in 2002 destabilized nearby glaciers. Landfast sea ice reformed in 2011, then broke up, with renewed instability appearing again in 2022. Hectoria Glacier's terminus stabilized after the 2022 austral winter, while Green Glacier continued retreating. Experts think the Hectoria system may slow and shift toward a fjord-like state, rather than sustain rapid calving. The findings highlight the broader relevance for tidewater glaciers on the Antarctic Peninsula and the region's response to warming, with implications for future coastal environments and sea level rise. Between January 2022 and March 2023, Hectoria Glacier retreated about 25 kilometers, including a rapid 8-kilometer loss in 2 months, the fastest documented grounded ice loss in modern history. New NASA and partner technologies, such as NISAR and SWOT missions, are emphasized as valuable tools for monitoring rapid glacier changes and their cryosphere impacts. Ice thinning persisted during the 2022 austral winter, as ICESAT-2 data revealed earthquakes beneath the glacier indicating a relatively flat bedrock and the formation of an ice plain that enabled large-scale calving. Naomi Akwat and colleagues warn buoyancy-driven processes could threaten larger glaciers under warming, potentially increasing sea level contributions. The retreat occurred in 2 stages. Initial loss of the ice tongue and grounded ice in 2022, followed by a second stage in 2023, driven by buoyancy after land-fast ice embayment broke up in January 2022 due to ocean swells. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.